For the extrude feature, we'll want this to be a closed profile. I'll press the Escape key to get back to the selection arrow, and you can see the green flags which identify the automatic relations that were added as we sketched. In case you don't see the tangent relations or these coincident relations, keep in mind you can add these manually as well. Let me give you a quick reminder. I'll delete this relation flag by clicking on it and pressing Delete on the keyboard. Now you can see that the line is no longer tangent to the arc. If an automatic relation was not created, you can add it manually by selecting the arc and Control-selecting the line, and choosing the tangent relation from the pop-up or from the Property Manager. Next, we'll fully define the sketch using dimensions. To launch the Smart Dimension tool, I'll press the S key from the keyboard, and I'll begin by giving the tab a height dimension. I'll choose this line segment and the arc. And notice that SolidWorks snaps the dimension onto the center point of the arc. I'll click again to place the dimension and type in 50 millimeters. In case you want this dimension to attach to the arc itself rather than the center point, you can actually move this endpoint of the dimension just by clicking and dragging. And you can see that SolidWorks snaps into the new position. For our example, I'm going to keep the endpoint onto the center point of the arc. Next, I'll give the arc a radius value. I'll click on it, type in 25 millimeters, and press Enter on the keyboard. Moving on, I'll create an angle dimension between this angled line and this horizontal line, and type in 75 degrees. I'll repeat this process for the opposing line segments and produce an angle of 75 degrees. At this point, notice that most of the geometry is still blue. If it's unclear which dimensions you still have to add in order for the sketch to become fully defined, I always recommend pressing Escape on the keyboard to get back to your selection arrow, and then clicking to move the geometry that's still underdefined. I recommend clicking on a combination of points and segments to see what you're still able to move. In this case, our geometry is still free to move from side to side. The design intent of this part calls for the tab to always stay centered with respect to the base extrude geometry. So how do we accomplish this? Well, one approach would be to utilize dimensions. We know that the overall length of the rectangle is 150 millimeters, so we can create a dimension of 75 millimeters from the edge to the center point of the arc. Although this would be a sound approach, I would prefer to use geometric relations to ensure that the tab always stays centered, in case our base geometry ever changes down the road. To do this, I'll create a center line to use as a reference to make sure that this tab shape stays centered directly above the origin of the part. Notice next the line tool here in the toolbar. There's actually a drop-down arrow where I can choose from a line or a center line. I'll activate the center line tool. And to begin, I'll make sure that the pointer shows the yellow flag when I'm on the center point of the arc, indicating the geometric relation will be added. And for the next endpoint, I'll select the origin of the base part. Again, I'll make sure that the yellow flag appears for the geometric relation. To complete the center line, I can either double-click or press Escape to get back to my selection arrow. With the center line added, the geometry is still free to move from side to side, but if I add a geometric relation on the center line by clicking on it, I can choose to make this center line vertical. When I do, the geometry turns black and fully defined. By making the center line vertical, I can be sure that the arc is always directly vertical with the origin. Now at this point, the sketch is fully defined and we can move on to create the feature. But before I do, I'd like to show you a couple more tools in the sketch environment. In this example, I use two angular dimensions, but perhaps I want these segments to always have the same angle. If the design ever needs to change under our current dimensioning scheme, I would have to change both dimensions manually. To incorporate a little bit of design intent, let me show you another approach. I'll click on this dimension to highlight it and press Delete on the keyboard. I'll press Escape to get back to my selection arrow, and at this point, you can see that this angle is now free to move. If I want to ensure that this line segment is always the same angle as this one approach is to use symmetry. I'll add a symmetric geometric relation by selecting this point here, holding down the Control key, selecting the center line, and with the Control button still pressed down, I'll select this endpoint here. With all three entities selected, SolidWorks shows me that a symmetric relationship is possible. I'll click it from the Property Manager, and you can see this sketch turns black again. With this design intent, if I change this angular dimension once, you can see that both segments update to maintain the symmetric relationship. I'll switch this back to 75 degrees by double-clicking on it and clicking the green check.